Have you ever wondered how JavaScript handles asynchronous operations? It's a fascinating process that unfolds behind the scenes, making your code run smoothly and efficiently. Firstly, JavaScript uses a mechanism known as callbacks. Picture this, a function nestled within another function, waiting for its moment to shine. This inner function is the callback function, passed as an argument to the outer function. It bides its time, only springing into action when the outer function completes its operation. Imagine a code snippet. Here, fetchData is a function that takes a callback as an argument. It uses a setTimeout function to simulate an asynchronous operation. When the operation completes after 1000 milliseconds, the callback function is invoked with the message, "Data fetched successfully." When fetchData is called with a callback function that logs the result, the message is printed to the console after the delay. But there's more to asynchronous JavaScript than callbacks. Enter promises. Promises are like well-mannered children. They promise to do something, and they won't rest until they've done it. A promise represents the eventual completion or failure of an asynchronous operation and allows for the chaining of such operations. In a typical scenario, fetchData returns a new promise. This promise is resolved after 1000 milliseconds with the message, "Data fetched successfully." When fetchData is called, it returns a promise. The then method is then used to register a callback that is invoked when the promise is resolved. If there's an error, the catch method is used to handle it. Yet, the sophistication of asynchronous JavaScript doesn't end there. With the introduction of ES8 or ECMAScript 2017 came async await, a syntactical feature that makes asynchronous code look and behave like synchronous code. It's built on top of promises and provides an even cleaner way to handle asynchronous operations and errors. Consider an example where fetchData is an asynchronous function that returns a promise. FetchData and process is another asynchronous function that calls fetchData using the await keyword. The await keyword makes JavaScript pause and wait for the promise to resolve or reject, then resumes the execution and returns the resolved value. Lastly, we have the event loop. Remember, JavaScript is single-threaded, which means it can execute only one piece of code at a time. But how does it handle multiple asynchronous operations concurrently without blocking the main thread? It uses an event-driven model with an event loop. The event loop continuously checks for tasks in the task queue and executes them when the call stack is empty. In summary, JavaScript's handling of asynchronous operations is a symphony of callbacks, promises, async, await, and the event loop. Together, these mechanisms enable JavaScript to run asynchronous code efficiently, making your web applications more responsive and user-friendly. So the next time you see an asynchronous operation in JavaScript, you'll know the magic that's happening behind the scenes.